everyone, this is AgenticMind. Today I will tell you about one. Here is my one project of applied time series forecasting. The at that this project I was done at my college, and so the topic is that time series analysis of hourly energy demand. In this project I will use ARIMA, SARIMA and the advanced forecasting model PROPHET. The PROPHET model is Meta. Those who are made the PROPHET model was made by or created by the Facebook metadata. So basically there are some of libraries from import NumPy, import Panda, import matplotlib, and the import functions for the time series analysis from stats model. Some stats models are there. I use in this project there are three methods to check the data is stationary or not. In the time series forecasting, we need the data is stationary. If data is not stationary, so we need to do the data stationary first after we are applying the time series forecasting on this data. So I take the data from the Niti Aayog website of Government of India. So here is hourly energy demand data. There are three. Let's go forward. Here is our data. There is a date column, time column, and hourly energy demand value in megahertz. So here I am implement some steps to set the data as a date time. So basically ensure the data is column date time format, causing errors to NAT. I will set the date column as a date time, and here the second step I implement the date column have some empty boxes, so I remove the null values from this date column using this condition or using this loop. So next step I was combine the date and time column to create a single date time column. Date and time, we have date and time column in the original data. I will combine those columns and proceed forward. Specify format for PD to date time consists passing handling 12 am to 1 am etc. So date time I was done some of the steps, and it's most important in the data which column you are applying the forecasting, means your target value. The drop df.drop na I'll set the date time column as our target value. So basically in the next step I set the date time column as an index, and the next step I will rename the hourly demand to the demand only, and df equals to next step I will date time list here ignores. In this step I drop the original unnamed 0 date time and date time strings columns as they are no longer needed. Display the updated data frame. So previous our data is this. After I applying these steps, our data is this. Only there are two columns. One is the date time that we will previously combine together, and demand column. Here are the plotting values, plotting code, but I plot all the visuals at last. I will show you properly all of these. So here I am implemented the stationarity check on the data using augmented decipher test. I will use in this project, there are three methods to check the stationarity of data. In time series forecasting, the data is stationary. Stationarity of data is required. If your data are not stationary, then the forecasting are not possible on this condition. So here implemented the stationarity check on the data using augmented decipher test. So after implementation, the ADF test gives the p-value. When we understand the data is stationary or not, the after checking from augmented decipher statistical test, they gives a probability value. If the probability value are less than 0.05, so that the data is likely stationary for time series analysis, and the p-value. So here is our value, 1 into 10 to the power 5. So here you will see clearly the result of a decipher test of the demand column, the p-value and some critical values they are giving on different significant level. So 1% significant level they gives a minus 3.43, and the 5% significant level minus 2.86, and 10% significant level minus 2.56. But we are check only p-value at that time. If the p-value 1.45, 4149 up to the 0.5, there is a exponential term. It means the value are less than 0.05. So this augmented decipher test we use the form of output the series are likely stationary. It means the data are able to use for the forecasting. So there will be next I implemented the KPSS test. I implemented in this project also ADF test, augmented decipher test, KPSS test, and also there is a one test are there. No, only two methods or two tests I have implemented in this project. So basically you understand all of these things. I implemented the time series forecasting on early energy demand. It means we are focusing or predicting the next 1 hour energy demand on the basis of data. So here is the KPSS test, also the same condition to check the stationarity. So the KPSS test after applying on data demand column, the condition is also same. The probability value is less than 0.05, so that the data is likely stationary. The time series analysis are possible on this data. So the p-value is gives the KPSS test is 0.01. So we are focusing on the p-value only. If after applying the KPSS test we are got the 0.01 value, it's less than 0.05. So this test is also the gives the form of output the time series is likely stationary. If means that our data is the eligible or the applicable for forecasting. Here is the plotting visualization code, but I will show you the last all visualizations how it's comparing and how it's forecast the energy demand. Here I will use the standard splitting formula. I have original 100% of original data. I will split into 20% and 80%. 80% is our training data, 20% is our testing data. Here you will see the how many data size are in the training and testing. You will see there as a training, the training data size is 10,483 and testing data size is 2,621. Here I implemented the ARIMA model. You also sees the ARMA and SARIMA model. ARMA model is used for the only implementing ARIMA. There is no seasonal component in ARIMA model. The full form of AR and MA model. There are both different models. The basically AR is the autoregressive model and MA is a moving average model. I implementing both the models are similarly on the basis of the ARIMA model, which value they are choose to or shows the output in the form of there will be use the AIC or BIC value to find the best order of forecasting. Means ARIMA model give you the order of like this candidates 1 0 1 0 1 0 1 0 1 2 0 1. The first value of AR autoregressive, the middle value of 0 is the differencing. When we require differencing is required only if your data is not stationary. That time you will need to proceed through differencing. And the third term is moving average. So here we are applying all of these AR models on the basis of AIC and BIC value. So after they are calculating all of these things. So here is I will show you directly the best order is that the best order of BIC, which means both AIC or BIC are the matrix to check the which is the best value for forecasting or which is the best fitted model for forecasting. So our ARIMA model is that 102 is the best model for the forecasting. It's the best order. So the AIC or BIC are both matrix term which are give the similar type of values. So the best order of ARIMA is that 202. It means AR2, differencing 0 and moving average is 2. We will go forward. Here are some SARIMA matrix are there. ARIMA. You will see the values of AIC, BIC, some coefficients, standard deviation are also calculated, and some values. We are also use the Lunjbox test and heterodicity, skewness, and kurtosis, skewness, probability. All of this we are calculating in this. This project is best for if you are studying the applied time series forecasting subject in your at your semester exam for semester of college. So here I was implemented the SARIMA model. There some mistakes are there. SARIMA. No, it's only SARIMA model. It means the SARIMA model. Seasonality, autoregression, and moving average model only. There is no differencing. I is integrated. Integrated means there is a differencing are there. If at the first we check the differencing, we have the data is stationary, so there is no need to check the differencing. Here is the SARIMA stats model we are implementing here. So there is a candidates are there of a SARIMA model 202, 100, 24. 24 is the seasonal cycle are there also in SARIMA model. The best order of our ARIMA model 202. Here the 202 of SARIMA's candidates. So let's forward we check the which is the best order of AIC. Here SARIMA model they gives the AIC values. 202 is the best model from our after checking our ARIMA, and then the SARIMA we are implemented after this gives our This gives the value of 10024. There is the 24 means the 1 days cycle, 24 hours cycle. Here also we are skewness and other things are calculated. Lunjbox Test, skewness, kurtosis, all values we are calculated. A covariance matrix is calculated using the outer product of gradients. Also, covariance matrix is singular or near singular with condition number 7. There is a value of a standard error may be unstable. Here are we PDQ a best order. The calculated order we are fixing on this model. So we are checking the residual analysis. So residual equals residuals res dot residu vr function that function we are used to calculate the residuals. Here the residuals are there. So here we are also implementing the Lunjbox test. The Lunjbox test is implemented to check if you know why we are implementing the Lunjbox test. Here the answer are also provided for you. Residuals of a time series model are random or if there is a significant autocorrelation remaining. If you are done in your college, ACF, PACF means the autocorrelation function and partial autocorrelation functions. Those methods you are or statistical sums method you are use or known well, then you understand this project. Otherwise you will lack to understand the project, this mini project. Predictable patterns in data, leaving behind random noise, white noise. If the test reveals remaining autocorrelation indicated the model is not a good fit and its prediction could be inaccurate. There is also we are implementing the Lunjbox test for autocorrelation. The residuals are autocorrelated with each other, then we go forward to forecasting. Here the value of Lunjbox test, the p value and the stats value. Model evaluation on mean square error, root mean square error and means absolute error. Here is the matrix which we are find our model is a good fit for the data or not, or it gives the best output or not. Here is the SARIMA model evaluation. We are evaluating SARIMA model on the basis of mean square error, mean absolute error, root mean square error. You know the very well, otherwise you are not understand this. Determine we also calculate the AIC or BIC of a SARIMA models. Also there AIC values SARIMA or AIC values of ARIMA. Here is our first visualization of comparing. I was compare the AIC and BIC values of each order for different SARIMA models. Here you will see the order which we are taking. It's only comparison. Those values are higher or greater, we will take those order. Here is our I will all visualizations I will combine together at the last. We'll see. Here are our models. First of all, I will explain all of these visualizations properly. Here is our original data. It's a forecasting, it's a visualization of original demand data. We are also visualize the autocorrelation function and the partial autocorrelation function. There is a If you compare these, it's the ACF are gradually decaying. It means here this graph shows a gradually decay are there, and the PACF are not gradually decay. After 2 points, they are sudden cutoff are there. Here is our residual of a SARIMA model. We are forecast also SARIMA model. Residual analysis are also we do in this case. Here the comparison of AIC and BIC values. Here are the SARIMA total forecast order. We are calculating the order of a model using AIC BIC value forecast. Here is the actual forecast. Here the red is a future forecast. The training data, our original data, our actual test data. Red color is actual test data, and the SARIMA order is the prediction. Our future prediction is this, as per you understand. So here I implemented the advanced forecasting model Facebook metadata Prophet. You also very well known the Prophet, what is Prophet and how it's working for forecasting. So I will show only how I was forecast the early energy demand on the basis of early energy demand. So here I am implementing the Prophet model, advanced forecasting model. Some libraries I use. You see. I also display the all features they will required in the different from ARIMA and SARIMA model. The difference between Prophet and SARIMA model. The Prophet model is used for complex seasonality pattern. It captures the complex seasonality, and they also calculate the trend, holidays, and different level of trends model and cycles they are calculating. It's mainly used for the complex forecasting only. Means they're having a different cycles, means weekly cycle, yearly cycle, or monthly cycle are there. So for that we are used for complex seasonality. The Prophet evaluation matrix are there. We also calculate the mean square error, mean absolute percentage error, or root mean square error for our better evaluation of a model. Previously I will show you the actual forecasting of a predictive forecasting of a SARIMA model, ARIMA or SARIMA. Here is our Prophet forecasting. Here is our actual data, means historical data we are taking from another scratch website, and the red color is that actual test data. Our test data is here, and here is the forecasting. This project or this data shows the this type of output. It means it's not predicting good or well. The energy demand are reduces. The model are not good fit on the data. Here I will provide the conclusion also. You will see. It is the Prophet forecasting of a monthly cycle. All of this we are done use. And first of all, those who are watch our video first time, then subscribe the channel and like the video. So I will share all of this type of videos and my all experience of my college I will share to you on this channel only. The AgenticMind is for you. Provide support, show your pleasure to this channel and press the subscribe button. I will also provide lots of video. Your one hand, it's my motivation. So please subscribe the channel and like the video. We will meet in next video. Up to the Thank you. Bye bye.